Hello everyone and welcome to the new episode of our series of solving LeetCode Daily challenges. And today we are going to solve a problem called Asteroid Collision, which has medium difficulty. So without further ado, let's move to the problem statement. We are given an array asteroids of integers representing asteroids in a row. For each asteroid, we know its size, it's represented by its absolute value, and the sign of this integer represents the direction in which an asteroid is moving. And if it's a positive number, then it moves to the right, and if it's a negative number, it moves to the left. Sometimes our asteroids collide. If two asteroids collide, then the bigger one survives and the smaller one gets destroyed. And if two asteroids of the same size collide, then both of them get destroyed. We need to find out the state of the asteroids after all of the collisions performed. Let's look at the constraints. So the number of asteroids is between 2 and 10,000. The size of the asteroid is between -1,000 and 1,000. And the asteroids cannot be 0, which means that they always move in some direction. Okay, so this constraint of 10,000 actually tells us that it's possible that big O of n squared solution will work, and we will discuss it quite soon, but we will also discuss a much faster solution as well. So let's do just that. So let's start from big O of n squared solution. So we are going to have an iterative process, and on each iteration, we are going to find the pair of neighboring asteroids that collide, and we are going to perform the collision. As a result of this collision, total number of asteroids decreases either by 1 or even by 2. Therefore, we are going to perform no more than an iteration. And each iteration takes us big O of n time, and therefore our total complexity is big O of n squared. However, we can do much better. And now I'm going to explain in details the big O of n solution. Okay, so we are going to iterate through our asteroids from left to right. And we are also going to maintain a stack of asteroids that are moving right. Here it is. I'm going to show you an example quite soon. If we meet an asteroid moving right, meaning a positive number, we just add it to a stack and nothing else. If we meet an asteroid moving left, we are going to perform the collisions with asteroids moving right, in the order of stack. And why do we need an order of stack? Because if we meet an asteroid moving left, then at first it's going to collide with the latest asteroid moving right. And as you will see quite soon, this is exactly the order of stack. First in, first out. Okay, so let's look at an example. Suppose we have an asteroids array that looks like this. So let's iterate it from left to right. So at first we meet the asteroid moving right with the size of 2. Let's just add it to the stack. Then we meet an asteroid moving right with the size of 5. We also add it to the stack. Then we meet an asteroid with the size of 7, but it moves to the left. And we need to perform the collisions. And the first collision that we are going to perform is this asteroid of size 7 and this asteroid of size 5. And now you see why the stack order is important. So this stack of size 7 destroys this asteroid of size 7 destroys this asteroid of size 5, so we just pop it from stack. Then our asteroid of size 7 destroys the asteroid of size 2, and we pop it from stack. And actually, turns out that this asteroid of size 7 basically destroys all of the asteroids that it collides with, and therefore it belongs to our resulting array. So let's add it to the resulting array, and let's move forward. The next asteroid we meet is moving to the right, and it has a size of 3. We add it to the stack. Then we meet an asteroid of size 8 that moves to the right, add it to stack. Then we meet an asteroid of size 5 that moves to the left. When we are going to do a collision with this asteroid of size 8, it will get destroyed. So we do not add it to the resulting array, and we do not modify the stack in any way. Then we, in the end, we meet the stack of the, we meet an asteroid of the size 6 that moves to the left, and we are going to collide it with the asteroid of size 8, and this asteroid of size 6 gets destroyed, and therefore it will not belong to the result, but these two asteroids that are moving right will actually belong to our result. So we are going to add them in order. And that's pretty much it. The resulting array is -7, 3, 8. And this is only asteroids that are going to survive in the end. Okay, let's look at the implementation. So we have an implementation in C++ today, and we are going to create a vector that will be our resulting vector. We are also going to create a vector that will represent our stack. So we will not use stack of int because it's notorious for its bad performance. We are going to use vector instead, but we will use it exactly like we would have used stack. So we will add to the end, pop back, and do stuff like that. And okay, we are going to iterate through all our asteroids, and if the asteroid moves to the right, then we are just add it to the back of the stack. And if it moves to the left, then we are going to have a variable that we are going to call destroyed. It's a Boolean variable, and it will just signify to us whether a given asteroid gets destroyed. So, and then we are going to have a nested loop. And while we still have some asteroids moving right, and our current asteroid is not destroyed, we are going to find a value of the opposite asteroid. And if it's bigger than our current asteroid, then our current asteroid gets destroyed. If it's equal to our current asteroid, then our current asteroid gets destroyed. And this opposite asteroid also gets destroyed. So we pop from our stack. And otherwise, only our opposite asteroid gets destroyed. And we, in this case, we simply pop from the stack. After this iteration is done, we are taking a look at our destroyed flag. And basically, if our current asteroid is not destroyed, we are adding it to our resulting vector. And in the end, we will just iterate through all of the asteroids traveling right that are not destroyed, and we will just add them to our result, and we will return the result. And that's basically it. Okay, guys, now the important moment. What's the complexity of this solution? I'm stating that the complexity of this solution is big O of n. And once again, it's all about amortized analysis. So at first sight, it looks like we have two nested loops, and therefore our complexity is big O of n squared. But as I always say, it's not about how many nested loops we have. It's about how many operations in total do they perform. Let's take a look at how many operations does this while loop perform. So in total, we have exactly n asteroids, and each iteration of this while loop either destroys one asteroid moving left. This means that we will never take a look at it again, or it gets rid of an asteroid moving right. So basically, we will never ever again are going to take a look at this asteroid. Or even better, it destroys both. Therefore, since we have only n asteroids, this while loop in total will never perform more than n iterations in total. And because of that, our complexity is big O of. Okay, guys, thank you very much for your attention. I think that this problem is very interesting, very fun problem, because you don't need to know any specific algorithms to solve it. You just think hard about the problem, and then the solution comes up to your mind. I hope you liked my explanation. If you like my channel, please press like, subscribe, and if you have any questions or any comments, don't hesitate to leave them under this YouTube video. Thank you very much for your attention, guys, and I hope you have a very nice day. Bye bye.